Hi guys, this is Ableton Bible, and in this video we're going to take a look at how to increase the stereo width of your mix and just general stereo widening techniques. Okay, so before we actually go into the techniques used to widen a stereo image, first we just got to talk a little bit about the difference between a mono sound or a mono signal and a stereo signal. So with a mono signal, this is basically just a single cable or a single channel that's used to take the signal down a line, and then when it gets to the other end of the line, then it can go to multiple speakers, but ultimately they're going to be playing the same signal. Whereas if it was a stereo signal, then it will be dual cabling, so it will be two wires for your left and for your right, and it will go down and they will go to separate speakers, so each speaker is playing something separate, and that's what's going to give us our stereo image from the left speaker across to the right speaker. So now we know that mono is one channel, whereas stereo is two channels, one for the left and right. And stereo, there's a difference between the left and right channel. So we can still send mono down dual cables left and right, but it will just be the same signal on each side. So it becomes stereo when there's a difference between the left and the right, and that can be a difference in either time, amplitude, or frequency content. We're now going to take a quick look at some of the basic psychoacoustic theory so we can understand how to make sounds a lot wider. So the first psychoacoustic effect is the interaural time difference, or the ITD. And what this basically means is if I'm sat facing my front and there's a person to the right hand side of me clapping their hands, then that clap sound, that's going to reach my right ear earlier than it's going to reach my left ear, because the right ear is going to be ever so slightly closer to the sample. And so because of that, we're going to hear the sound being perceived as coming from the right hand side. Next, we've also got the interaural amplitude difference, the IAD. So it's exactly the same concept as the ITD, apart from this time it's over amplitude instead of time. So if we go back to our situation where I'm facing my front and to my right hand side there's a person clapping, the sound is going to be ever so slightly louder in the right hand side than it's going to be in the left hand side because of the way that things are reverbing around a room, the fact that my head's in the way. All these little factors are going to build up to mean that there's slightly less amplitude in the left ear, so I'm going to perceive the sound as coming from the right hand side. Another little thing worth mentioning is that the time difference always takes precedence over the amplitude difference. So if you hear it come into the left hand side first, it doesn't matter how big the amplitude is on the right hand side, you're still going to think that it's coming from the left. So if we look at Ableton's pan pot, this actually uses the amplitude technique that I was talking about a minute ago. So if we pan all the way to the left, we're only actually going to hear the amplitude from the left signal. If we pan it all the way to the right, we're only going to hear the signal from the right hand side. So if we actually hard pan a stereo sound, we're actually making it mono. So this is something to bear in mind. So another little thing that we need to bear in mind is if we've got a difference in frequency or pitch between the left and the right channel, then that is also going to give us a wider stereo image. So the reason this is because your left ear and your right ear aren't going to pick up sounds exactly the same, depending on where the sound's coming from, where you are in a room, how the sound's reverberating. There's loads of factors that means there's going to be a difference in frequency between the left and the right ear. So that's something we can use to our advantage. Finally, the last thing we need to understand is that as a sound travels through air, higher frequencies are going to be dissipated faster than lower frequencies. So what that means is these higher frequencies are going to be dampened the longer distance they have to travel. So the reason for this high frequency damping is basically because higher frequencies are dissipated over greater distances because of the size of the wavelength. So if we think of a really high frequency, it's a high pitch, which means it's going to have a really, really fast cycle, which means it's going to have a really, really short wavelength. And because it's cycling more times per second, there's going to be a lot more energy lost the further it has to travel. Whereas lower sort of bass frequencies are going to travel a much greater distance without losing energy. And if you think about like a club, when you stood outside a club at night and you can hear the bass coming through the walls, and that's the same sort of thing. Those bass frequencies are going to get projected much further because they're not losing as much energy. When we're using stereo widening techniques, we've got to be extra careful of phasing and any phase issues. So we can use a phase correlation meter or a vectorscope to make sure they're not going to get too much phasing. And if we do, we can then pinpoint where it is and either reduce it or go into that instrument and sort out the reason why it's phasing. So to understand phasing, we've got this little project here, and if I just press record, what it's going to do, just so you can see, I'll just rename these. Sine 1 and sine 2, and they're identical and they're exactly in line with each other. and this is resampling. So all this is going to do is record the 2 sine waves. So if I just hit record, as you'd expect, at the moment what we've got is we've got a doubling in amplitude because they're exactly in phase with one another. And if we take this grid off, what we're going to do now is we're going to slowly add a time to this, which is changing the phase, known as phasing, which is also what we're doing when we're creating a stereo effect. We're creating a difference between the 2 sine waves. And we'll notice that when we get to certain positions, when this is directly out of phase with this, then we're not going to get any sound. So if I just show you. Okay, so that's just pretty much, if you have a look, pretty much at anti-phase now. And then as we go back even further, so about there, go back through to normal phase again. So we get a summon again. And that is phasing. So if we think about that with a more complex sound, obviously this is just with a sine wave. If we think about that with a more complex sound such as a piano, which is made up of hundreds of sine waves, each at different frequencies, then as we start to split a sound in the left and right channel, when we start to add a time delay to one of the channels, then what we're going to get is we're going to get this effect at certain frequencies. So we're going to get notches at certain frequencies throughout our frequency spectrum, which is going to give us that phasey type sound, which is not what we want. So to keep an eye on phase, we can use plugins such as the BX meter, which is a Brainworks phase correlation meter. So as we can see here, we've got the balance left and right, so it shows us where the pan position is, and we've also got the correlation meter. So if I press play, this is just some stereo drums. So if it's up near the +1, then if I just use a utility effect, be able to see, so bring it to the +1, that means it's mono, and we'll go to 100%. So this is showing us that we do have some stereo content on these drums. And what we can actually do is we push this up. You can see as the phase correlation meter starts going down, and this is when we start getting problems when it goes below 0. So personally, I'd say it needs to stay up in this sort of top quarter. Obviously, as you start to build your entire mix, the more things you put into the mix, the more elements, the more there's going to be some more stereo parts that might contribute to having anti-phase. But if we push this all the way up, then we can see that's right the way down, and that is 100% not acceptable in a mix down, because it will just completely ruin the mix when it's summed to mono. So the next thing we've got is a vectorscope. So we can sort of look at that as similar to a phase correlation meter, but it just goes into a little bit more detail. So we can see a mono signal is just a straight line going through, and with stereo signals you're going to get a bit of scattering depending on what sort of mode you've got it in. You've got polar sample in this case, polar level, or deciduous. And in polar sample mode it's going to put little dots for all the different samples, and we want to generally make sure that it's not going too wide. If it's going into these left or right quadrants, then we've got issues that need to be addressed. Okay, so we've talked enough about the actual ways we can meter and reference the effect we're doing, and we've talked enough about the psychoacoustics, so now we can actually look at the techniques. So for this, we're just going to use these mono drums, and the first technique is called the frequency shifter technique. So just put that on the drums and press play. So we can hear we've got our mono drums, and the frequency shifter can shift this entire loop either up or down in frequency. So a bit like a pitch shifter, but it does it in hertz instead. And we've also got a fine control down here. And we can also use this as a ring modulator as well. So these are the two modes, and we've got an LFO that will work on either the shift or the ring modulation. But what we've also got, if we click this wide button, is it changes the fine control into a spread. And what this is going to do is, as we push this value up, it's going to shift the frequency of the left channel up while shifting the frequency of the right channel down. So just listen to how that sounds. You can start to hear we've got a bit of stereo width there. And we need to be careful not to go too far with these controls, because as we go up further, it's going to start to split apart, and we're going to be able to notice the difference in pitch between the left and the right channel. So a thing to be aware of when we're doing this technique is that when this gets broken back down to mono, we're going to have a pitch difference, so we might get some weird sounds. So we've got to be careful how far we push it. If we listen with it in mono while we do this adjustment, it really doesn't sound good. So while this technique works well in stereo, I'd say if you're going to have mixes that are going to be played in mono, it's probably not the best of ideas. The next technique we're going to use is called the Haas effect, or the president's effect. And what this basically means is if we have a sound, it can come from two different directions, and as long as the sound is within 5 to 35 milliseconds of each other, then we're going to think it's the same sound. So what we can do to emulate this is if we use a simple delay, and what we do is we turn the dry wet all the way up, and the reason we turn it all the way up is because we don't want to hear a mash of half dry, half wet signal. We just want the wet signal, because what the wet signal is going to do is going to split this into two delays, into the left delay line and the right delay line. And at the moment, if we listen, this is going to be like an actual delay effect. So if we listen, which isn't what we want. And if we turn the feedback up, then that delay effect is going to get even more obvious. So we'll just have a listen. Okay, so the feedback has got to be on 0, and what that means is there's only going to be one repeat. And we'll keep link off because we want the left channel independent from the right channel. We'll turn time on. We'll bring this down to 1 millisecond. So now the left channel and the right channel are at the exact same time. And as we increase this time parameter between 5 and 35 milliseconds, we're going to get the Haas effect. So we'll just listen. When we get to about 35 milliseconds, we can start to hear the left and the right channel split apart. And as we start getting above sort of 70 to 100 milliseconds, we can start to hear this as an obvious delay effect, like a slapback delay. So when we use this technique, we need to be aware of monocompatibility again. So if we put a utility plugin on, so what I'd say is find somewhere roughly where you want it to be. So I think it sounded good at about 25. And have a listen and reduce it to mono and see if it still sounds a bit odd. What you can do is just fine tune it until you get that point where it's least phasey, or you get the least amount of issues. So I think that sounds alright. If we take it back to stereo. And the reason we do this is because if something sounds good in mono, then the chances are it's going to sound good in stereo. Whereas going from stereo to mono, sometimes it doesn't work like that, as you heard with the frequency shifter effect. So there are other ways we can do the Haas effect. So another way is if we just duplicate this. So now we've got left and right. What we can do is pan this to the left and pan this to the right. So this is doing similar to what we just did in the simple delay. And then we can turn on this delay line down here, the track delay. And exactly the same as before. Just play that as well. Exactly the same as before. You can just creep up this track delay, and it's having the exact same effect. And finally, another way we can do it, if we decide we're going to duplicate the channels like this, then put the simple delay back on. Because we've now got a left and a right, then all we have to do, instead of having this, we'll have this back at 100% wet, feedback all the way down. This time we turn link on, and the reason this is because now this is going to be our left channel, this is going to be our right, so there's no point splitting this right channel into left and right again. And there are other ways that we can increase this even more. So what we can do is we can also add things like saturation or EQ, because remember, all we're trying to do is make a difference between the left channel and the right channel. So for example, put an EQ on here, and we'll just create some notches. Just move these up a bit. Take these, fairly high Q factor, just bring it down by maybe -5, -3. And what we can also do is add a bit of saturation. And you've got to be careful with saturation, because as you add saturation, you're going to add level. So you need to sort of make sure that you remove on the output what you're adding with the drive. So if you just have a listen. So what we've got there is we've got the delay, then we've got removing a bit, so what we're actually doing is dulling down the frequencies here. And then we've also got the saturator, and what we can also do is we can copy this, drop it onto the other one, and this is only going to be very subtle, but what we can then do is just move these slightly, so it's going to affect slightly different frequencies. So that's basically a bit like comb filtering, but on a much more subtle level. And just to hear that this is definitely working, what we can do. So that's just left and right. So the Haas effect on its own. This one's going to be quite subtle. And saturator. And all of them together. So that's a few different ways that you can use the precedence effect or the Haas effect. So the next effect is the chorus effect. So if we just play our melody loop, and we'll just drop a chorus on there. Okay, so straight away, as soon as we drop that on, you can hear that we've got a little bit of loss of the transient, so it's less defined for the where it's being panned to. And you get best results at around 50%, because what we basically got is this mimics how when there's multiple people singing, you're going to get fluctuations in timing and pitch. In this case, it's just timing. So we've got delay 1, delay 2, and then we've also got the original signal because we're at 50%. If we was at 100%, we're just going to get 1 and 2. So put that back to 50%, and we'll just play that. And what we can do is at the moment, this modulation is only this LFO is only affecting delay 1. So we can find somewhere fairly subtle. And what we can also do is turn on delay 2. So now we've got the original delay 1 and delay 2. And if we want this modulation to affect delay 2 as well, then we can turn this on. So we'll put that around there. And off. And you can see how that just adds a bit more weight and thickness, and also increases the stereo field a bit, but this will reduce the transient slightly. Okay, for this next effect, we're going to be making a mid-side rack using utility. So let's drop a utility plugin on the track. And if we just listen to this, we can see here that this is mono because it's flat. So if we reduce this to mono, we get no change. If we push this to 200%, then we're not going to hear any signal because this is mono, there is no side information. We push this all the way up. This is now only letting through the sides, which is why we have no signal. So this is why it doesn't work on mono sounds. There's got to be some stereo in the signal already for it to work. So what we'll do is stop that. And here we've got some stereo drums. So I'm going to drag this over to the stereo drums. Put it back to normal. And we'll just play these. Just to see. That's how they sound mono. And if we push this up to 200%, that's the stereo information of the side information. So we can use this to our advantage to create a mid-side rack. So to do that, all we've got to do is right click on utility and group it with itself. And we can now go into the chains and we can name this chain mid, and we can duplicate this and we can rename this bottom one mid and sides. Well, we can now just go to the mid one and reduce it to 0 and the sides and push it to 200. So now this is just the side information and this is just the mid information. And what we can then do is go one further and open up the macro controls, map to macro 1, map to macro 2, mid, sides, and what we've got now is we've got control over the mid and sides, so we just get rid of everything else. And what you tend to find is that things like drums, often the bass, the snare, the power instruments, the vocal, they're going to be the lead vocal, they're going to be sat in the centre. So they'll be the mids, and then with the sides you've got things like reverbs, guitars, effects, they'll be in the sides. So what we can do is mid-side expansion, and all we've got to do is simply push up the sides a bit more. Okay, so this next technique I've decided to use Massive because a lot of people have this synth, so it's a nice and easy one to do. So all it is using Massive to add detune using the Unison and also spreading with the pan feature. So just listen to this little clip that I've made. Just get rid of these. So we've got a little deep house pattern going on. And now that we're in Massive, if we go to the voicing tab, here, Unisono states how many voices are going to be played per note. So at the moment, for each of these notes, we've got one voice. If we increase this to say 5, what this now means is for every note, there's going to be 5 voices. And we're not really going to notice this much apart from an increase in level at the moment because there's no difference between any of the voices. So we just have a listen. You can see that level creeping up. So what we can do to try and make this sound a bit more weighty, a bit more wider and take up a bit more space is we can turn on the pitch cutoff and the pan position. Just turn this down a little bit. And what this is going to do is it's basically how chorus affected the loop earlier. This is going to make a difference, a very slight difference in pitch to each of the voices, and this is going to spread each of the voices to a slightly different pan position. So I'll just show you how that sounds. So we've got to be quite gentle with the values. And pan. So you can really hear that making it sound more wide. So what we can actually do now is we can split the sound into different frequency bands using EQ3. So if we just have a listen to this. So to do this we need the EQ3 plugin. And all we do is we right click and group this with itself, and then what we can do is we can go into the chain selector using this button here and right click and just duplicate this twice. So now we've got 3 instances of the EQ3 running in parallel with each other, and then we just rename this high, mid, and low. And what we can now do is for the low we'll turn the mid and the high off. For the mid we turn low and high off, and then for the high we turn low and mid off. So now we've got sort of acting like a solo. And if we want to adjust the frequencies, then we can do that here, but we need to remember when we're doing the frequency adjustments, if we're changing the crossover for the lows, then we need to do that on the lows as well, and if we're doing it for the highs, we need to do it in the mids and the highs so we don't get a frequency overlap. So now if we listen, what I'm going to do is just pull this a little bit lower, 200, and we do the same with the mids. So we've got our sort of bassy frequencies, and we've got our mids. So now we can affect these differently to give more stereo width. So with the lows, what we're actually going to do is the opposite. We're going to take the stereo width away using this. You can hear straight away the difference that's made. Because sort of below 200-300 Hz, we don't really want any stereo information because it's just going to manifest itself as muddy, phasey sort of sound. And then with the mids, what we can do is we can run a chorus effect just to thicken it up slightly. So while it sounds like we're actually taking away stereo width there, we are in essence with the low band, but then we can add that back in with the mid and high band, and by doing that we're going to have less mud in the mix. So just to recap, in this video we've taken a little look at mono and stereo and the differences between them, and also the psychoacoustics involved as to why we perceive something as being wider than something else. We've also taken a look at phasing and how that can cause issues with the low end, and how we can reference and monitor that with plugins such as phase correlation meters and vectorscopes. We've had a look at frequency shifting. We've also had a look at the Haas effect, using delays and also duplicating. And as well as that, we've also had a look at frequency highlighting by using EQ, saturation and chorus. We've also taken a look at mid-side expansion and how we can make a custom mid-side rack using Ableton's utility. And we've also had a look at Unison, detune and panning voices in synths such as Massive. And finally, we've had a look at how we can split the frequencies so we can affect the high, mid and low ranges of certain tracks.